Today I am going to discuss inertness of nitrogen. First of all, let's try to learn about inertness and reactivity. Inertness and reactivity. Let's see what are those. Molecule, reactant molecule. At the time of reaction, molecule breaks into atoms or ions. At the very outset of a chemical reaction, molecule breaks into atoms or ions. If this breaking process is faster, then the molecule will be reactive molecule. But if it is slower, then it will be classified as inert compound, inert molecule. So reactivity or inertness, it depends on the breaking of the reactant molecules into atoms or ions. If the breaking is faster or with minimum amount of energy, then the compound will be reactive. But the breaking is slower or amount of energy which is applied here, if it is larger, then the molecule will be inert. This is actually inertness or reactivity of compounds. The faster a molecule breaks into atoms or ions with minimum amount of energy, then the molecule will be reactive. But if molecule breaks into atoms or ions with a high amount of energy or the breaking process is slower, then the molecule will be inert. This is inertness and reactivity. Now let's consider two molecules. Molecule A, diatomic molecule. Another molecule is B, diatomic molecule. If molecule A breaks into atoms or ions with a high amount of energy, then a molecule will be called inert molecule because it breaks into atoms or ions with a high amount of energy. That is why it's a kind of inert molecule. But suppose B molecule breaks into atoms or ions with minimum amount of energy. That is, molecule B breaks into atoms or ions very easily, faster, with low amount of energy. Then this molecule will said to be reactive molecule. Similarly, nitrogen molecule, which is our today's point, this is also a diatomic molecule. To break this molecule, it requires a high amount of energy, almost 3000 degrees Celsius temperature. At this high temperature, this diatomic molecule nitrogen breaks into atoms, nitrogen atoms. Because of the high amount of energy which is required to break this nitrogen molecule, nitrogen is called inert molecule. Why this is inert molecule? If we see structural formula of nitrogen molecule, then it will be cleared. Structure formula is this. Between two atoms, there are three bonds. Triple bond is present in nitrogen molecule. So, to break this bond, huge amount of energy is required. That is why nitrogen is used as inert medium. Now let's see formation of triple bond through hybridization. Formation of triple bond between two nitrogen atoms through hybridization. Atomic number of nitrogen is 7. Electronic configuration is 1s2, 2s2, 2p3. Let's write electronic configuration of nitrogen in box method. This is 1s orbital. This is 2s orbital. 1, 2, 3. 2px, 2py, and 2pz. 1s orbital contains 2 electrons. According to Aufbau principle, electrons will enter first lower energy orbitals, then 2s. 2s orbital contains 2 electrons and 2p orbital contains 3 electrons. According to Hund's rule, electrons will enter the degenerate orbitals one by one. According to Hund's rule. So, this is the electronic configuration of nitrogen. In the outermost shell, in the valence shell of nitrogen, there are 5 electrons, 3 unpaired electrons and 1 pair of electrons. In nitrogen molecule, nitrogen is sp hybridized. That is, here S and P hybridization occurs and 2 orbitals Py and Pz orbitals remain unhybridized. That is, orbital structure is nitrogen. After sp hybridization, 2 hybrid orbitals are formed. Sp hybrid orbital, another sp hybrid orbital. One sp hybrid orbital contains 1 pair of electrons and another sp hybrid orbital contains 1 electron, and 2 orbitals remain unhybridized. This is suppose 2py and this is 2pz. Another nitrogen atom, here 2 nitrogen atoms, sp hybridization occurs. One sp hybrid orbital contains 1 electron and another sp hybrid orbital contains 1 pair of electrons, and 2 unhybridized orbitals are, suppose this is 2px and this is 2pz. Now, between these 2 nitrogen atoms, first of all, sp hybrid orbital head to head overlap occurs, and as a result 1 sigma bond is formed. Then unhybridized orbital py and this py, through sidewise overlap, 1 pi bond is formed. This is py overlap, and another pi bond is formed, which is by the overlap of 2pz unhybridized orbitals. This is 2pz, here 2pz. This is 2py, 2py. So another pi bond is formed. That is, between two nitrogen atoms, three bonds are formed. One is sigma bond by the overlap of sp hybrid orbitals, and two pi bonds are formed by the overlap of py orbitals, and another one is by the sidewise overlap of 2pz orbital. In this way, between two nitrogen atoms, three bonds are formed. Because of the formation of three bonds, nitrogen molecule becomes stable. Because of the formation of strong bonds. Nevertheless, when nitrogen is heated at 3000 degrees Celsius temperature, then stepwise nitrogen molecule breaks into atoms in this way. First of all, one bond is broken. This one pair of electrons, here this pair and this pair. After breaking one bond, homolytic fission, one electron, one electron. Again, another bond is broken, and then one electron, another electron. Another bond is broken and two atoms are formed. One electron, another electron, three unpaired electrons. So this is the reason, that is presence of triple bond between two nitrogen atoms in nitrogen molecule. Nitrogen acts as inert medium. No more today. Thank you very much.